Welcome to this video. In this video we are going to discuss about the basic principle of operation of field effect transistors or FET. The figure shown here illustrates the basic operation of a field effect transistor. The device operates as a capacitor with one plate serving as a conducting channel between two ohmic contacts known as source and drain contacts. The other plate, called the gate, controls the charge induced into the channel. The carriers in the channel come from the source and move across the channel into the drain. So we can say that the field effect transistor operates as a capacitor with one plate serving as a conducting channel, and the other plate called the gate controls the charge induced into the channel. The two ohmic contacts at the ends of the conducting channel is known as source and drain. The charge carriers in the channel come from the source and move across the channel into the drain. Several kinds of field effect transistors based on the same principle of operation are available. Some of them are metal oxide semiconductor field effect transistor or MOS FET, or they are also called metal insulator semiconductor field effect transistor or MIS FET. Metal semiconductor field effect transistor or MES FET, junction field effect transistor JFET, etc. are some of the forms of field effect transistors working on the same principle of operation. These devices differ in the gate material, in the location of the gate with respect to the channel, and how the gate is isolated from the channel, and what type of carriers are induced by the gate voltage into the channel. I have already said that different kinds of field effect transistors are available, such as MOS FET, MES FET, JFET, etc. These devices differ in the gate material and in the location of the gate with respect to the channel, how the gate is isolated from the channel, and what type of carriers are induced by the gate voltage into the channel. For example, electrons are induced in n-channel devices, holes are induced in p-channel devices, and both electrons and holes in double injection field effect transistors. The schematic diagram of metal oxide semiconductor field effect transistor is shown on the screen. In a silicon MOS FET, the gate control is separated from the channel by a silicon dioxide layer. Here we can see an oxide layer. So the gate control is separated from the channel. This is the channel. This is the source, drain, two ohmic contacts, source and drain. This is the channel. This is the gate terminal. The gate terminal or gate plate is separated from the channel by an insulator layer or silicon dioxide layer. The very low density of interface states at the silicon dioxide interface make silicon MOS FET the most important device in modern electronics. In this kind of field effect transistor, the channel is created by the electron gas or by the hole gas induced by the gate voltage into the semiconductor at the silicon insulator interface. In this figure, the basic schematic diagram of MES FET is shown. Here, the channel can be partially or totally depleted by the gate voltage and by the built-in voltage of the Schottky contact forming a gate. Here, the channel, the source, drain, two ohmic contacts are on the sides of gate terminal, and the channel can be partially or totally depleted by the gate voltage and by the built-in voltage of the Schottky contact forming a gate. The isolation between the gate and channel formed by the doped semiconductor material is provided by the Schottky gate depletion layer that is controlled by the gate voltage. That is, by controlling the voltage at the gate terminal, we can make some depletion region between the gate contact and semiconductor channel. This depletion region provides the separation or isolation between the gate and the channel layers. The gate voltage changes the width of the depletion region and hence the cross section of the conducting channel. So it modulates the electric current in the channel. In a junction, this is this case of metal. This is the case of metal semiconductor field effect transistor. Next, we have junction field effect transistor. The schematic of junction field effect transistor is shown here. Here, a PN junction plays a role similar to the Schottky gate in MES FET. Usually, MES FETs and JFETs are fabricated from materials such as gallium arsenide.